Hello everyone. Today we are going to start lecture 06 of class 8th mathematics chapter number 1, which is rational numbers. In this lecture we are going to study representation of rational numbers on the number line. But before it we should know what is number line, and before number line we should know the basic difference between three geometrical figures, which are line segment, ray and line. Let us start with line segment. As the name suggests, line segment is a segment that is a part of a line. So it has two endpoints which are fixed and cannot be extended. Okay, so line segment is nothing but a geometrical figure having fixed length. Let us suppose AB is equals to 5 cm. Then this will always be 5 cm and you cannot extend A or B because the points are fixed. So line segment is used to represent various segments or parts where the length is fixed. But the numbers are infinite, so you cannot use line segment to represent numbers on it. Now the next figure is ray. This geometrical figure starts from a point but it does not end at any point. That is, it does not have an end point. So A is the starting point, but if I take this direction B, then B will not have any end. That is, you can extend it in one direction. Okay, so ray can be extended in one direction, that is, one of its end is fixed and the another end can be extended to any length. This is represented by an arrowhead over AB, where it is very clear that the fixed point represents the point from which the ray originates and the arrowhead represents the direction, that is, B represents the direction of arrowhead. So it clearly implicates that the ray is starting from A and heading towards B. Again, its length cannot be fixed but can be used to represent numbers which are extended only on the one side. That is, they start from somewhere but they do not end on the other side. And the third geometrical figure is line. As you can guess by now that line is something which have two arrowheads, that is, no starting or end point. So if I label them as A and B, we will get a line AB. We will get a line AB which do not have any length, neither origination, neither termination. So a line is something which have no origination point or no termination point, and it is represented by double arrowhead over its name. So it represents that AB can be extended on either side up till infinity. That is the only reason why we call it number line. That is why line is used to represent real numbers, because real numbers are infinite, in the sense that they can be extended on both negative and positive side, right? So these geometrical figures play an important role in presenting different kind of numbers on number line. Now let us start by representing natural numbers on number line. We all know natural numbers starts from 1 and they get increasing up till infinity. Okay, so we can use ray for this purpose, but for simplicity we will call it a line. Okay, in this, natural numbers are equally spaced, because you can see the difference between 1 and 2 is the same as the difference between 2 and 3, which is the same in the difference between 3 and 4, which is the difference of 1 unit, right? So all the natural numbers should be equally placed on the number line. We will start the number line, that is this ray, from 1 as it is the origination point, and then we'll mark the another point at some distance from 1. Now this distance has become the scale. Okay, so if you have to mark another point 3, then you have to take the same distance from 2 as we have taken from 1. Similarly, at equal distance you can mark 4, 5, 6 and so on. Also you can mark the points as O, A, B, C, D and E. From geometry also and from logic, by logic, that the natural numbers are, the difference of any two consecutive natural number is same, so they should be equally spaced. So OA is equals to AB is equals to BC is equals to CD is equals to DE and so on and so on. So when you represent natural numbers on number line, they are obviously equally spaced, right? This line extends, this line extends indefinitely only to the this line extends indefinitely only to the right side of 1. Only to the right side of 1. You can clearly see that there is nothing towards the left of 1 in case of natural numbers, right? We are talking about natural numbers, not integers. Otherwise we would have 0 on the left of 1. That is why we are using a geometrical figure which is used to have which have a starting point, because natural number have a starting point but do not have an end point on one side of it. Okay, now let us represent whole numbers. Again, whole representation of whole number would be identical to natural numbers. The only difference is that it includes 0. So what change does it make? The only change it will make is that your number line now will start with 0 and then you will go to 1, and then at equal distances you can mark off points 1, 2, 3, 4 and so on. Also you can name them as O, A, B, C and D. And here also by geometry also, by construction also, and by logic also, again the difference between any two consecutive whole numbers is again same like in the case of natural numbers. So here also OA is equals to AB is equals to BC is equals to CD, right? So this was the representation of whole numbers on the number line. Now let us move to the integers. Now here we have to officially use the geometrical figure called line. Why? Because integers do not have a starting point nor they have an end point, right? Integers don't have a starting point. If you can see that 0 is the middle point of the integers, right to the 0, integers can extend to infinity, and on the left of the integers and to the left of 0 again they can be extended to negative of infinity, right? Minus infinity. Because integers are what? They are natural numbers with plus and minus sign including 0. So 0 is the middle point. On the right side of it they have natural numbers, and on the left side of it they have negative natural numbers, right? So how do we represent integers on number line? We draw a number line, right? We mark the midpoint as 0. Then at equal distances we mark 1, minus 1, 2, minus 2, 3, minus 3 and so on, right? Also you can mark the point as O, A, B, C, A dash, B dash, C dash. Again from geometry, OA is equals to AB is equals to BC, right? Similarly OA is equals to A dash O is equals to B dash A dash is equals to C dash B dash. So you can see that again the difference between any two consecutive integers is 1, which is the same as whole numbers and natural numbers, so the scale would be same. Okay, now it is your choice to take scale, right? If you want, then you can take this distance to be 2 cm, 3 cm, 4 cm, but once you choose it, you have to take all the distances according to it, or I shall say equal to it, because if 0 to 1 is 5 cm according to your scale, if you have taken 5 cm equals to 1 unit, then again 1 to 2 is again 5 cm and 2 to 3 is 10 cm, 5 cm again. That is 0 to 3 would consume 50 cm of your notebook, right? So this should be remembered in your mind while you are making a number line or you are representing any number on the number line, right? Scale should be chosen first. Now let us come to the main topic, which is representation of rational numbers. Now we have represented integers. The representation of rational numbers is similar, but now it will involve fractions also. So let us take an example of a fraction and we should try to represent it. Let us represent half on the number line, right? So first of all we will draw a number line. We will mark 0 in between and we'll take a scale on a suitable scale. Let us take 1 here and minus 1 here. Let us mark the points as A dash and A, and let us mark the origin, that is 0, as O. Okay, now we have to represent half. Okay, you can see that if OA is equals to if OA is equals to 4 cm, Suppose we have taken 4 centimeter as 1 unit. Okay. Then if I place a point at exactly midpoint on ONA and let it be named B, then the distance OB would be, since B is the midpoint, so OB equals to half of OA, that is half of 4 centimeter, which is half of 4 centimeter, which is 2 centimeter. So if 4 centimeter is equals to 1 unit on your number line, then you can very clearly see that 2 centimeter equals to 1 by 2 units. Don't you think that we have just represented half on the number line? Similarly, you can mark in midpoint of O and A dash and let it be B dash, then you will get minus half. So it is that easy to represent fractions on number line. Okay, but you can say that it was very easy because you have divided the number line or the section between the number line, that is the line segment OA. Clearly OA is a line segment because there are fixed points on the line. So you have divided the fixed points into half, so it was very easy. Okay, so let us take another example where we can represent 1 by 3. Okay, now let us represent 1 by 3 on the number line. Again, the process will be the same. You have to draw a number line. You have to mark point 0. Okay, you have to mark point 1 on a suitable scale. We will represent both 1 by 3 and minus 1 by 3, right? Now let the points be A dash, O and A. Now again, if you have taken OA equals to 3 centimeter, let me write it. It will become a bit easier. Let OA equals to 3 centimeter. Now let me divide, because the denominator is 3. I will talk about this later in the lecture. But since the denominator is 3, I want to divide the section OA into 3 equal parts. For this purpose, I have to place 2 points here. Okay. Let the points be B and C. So OB equals to BC equals to AC. Since they are dividing OA into 3 equal parts, they are all equal to 1 by 3 of OA, which is equals to 1 centimeter, because OA equals to 3 centimeter. So they are all of equal length, 1 centimeter. Now you have chosen 3 centimeter to be 1 unit on the number line. So you can very clearly see that all of these are 1 by 3 of OA, that is 1 by 3 of units. So they are all 1 by 3. That is OB, the distance OB represents 1 by 3 units. The point will be the stop 1 by 3, right? Again, since OC is equals to OB plus BC, that is 1 by 3 plus 1 by 3. So C will represent 2 by 3. But continuing with this logic, OA is equals to OB plus BC plus CA, that is 1 by 3 plus 1 by 3 plus 1 by 3. So it would be 3 by 3, which is true. See, which is true. So our method is valid and it is very easy. Again, you can here take 2 points which equally divides OA dash into 3 equal parts, and you can name them B dash and C dash. Again, it will be minus 1 by 3 and it will be minus 2 by 3. But by this logic, minus 1 equals to minus 3 by 3. So it is true. So it is that easy to represent rational numbers on number line, right? Let us move forward and represent 2 by 3 and minus 2 by 3 on the number line. Now I will teach you 2 methods how to do that. In this lecture, we are going to learn 2 methods. So we have to represent 2 by 3 and minus 2 by 3 on the number line, right? So let us talk about the first method, and let me draw the number line. This method simply says that mark the point 0. Now see the numerators. Okay, the numerator is 2, so it says that on a suitable scale as per your choice, mark the numerators on number line, but now the scale is chosen, so I have to take 0 to minus 2 as the same distance as 0 to 2. Okay, so I have represented this. Now the method simply says that see the denominator and divide the space between 0 and 2 into 3 equal parts. Now for dividing it into 3 equal parts, you have to take 2 points. So we have placed 2 points here, right? Similarly, you can divide them into 3 equal parts. You will place 2 points here. So let it be O, let this point be A, and let this point be A dash. Okay. Now let the points be B and C, and let these points be B dash and C dash. So according to this method, it simply states that the first point, that is when you divided the space into 1/3 part, the first point will represent the required number 2 by 3. And similarly here the first point will represent the required number minus 2 upon 3. So what we did is we just represented numerator on the right and left hand side, and then we divided the length between origin and numerator into the number of parts which are equal to denominator, and the first point will represent your number. Now what does the second method tells? Second method is a bit similar, but it is a bit different too. So let us talk about what it says. It says that firstly draw the number line. Okay. Now before marking 0, first of all identify that where your number lies. Now let me approximate 2 by 3. So you can clearly see 2 by 3 is in this fraction, numerator is smaller. So this number is greater than 0 because it's positive, and it is less than 1. So 2 by 3 lies between 0 and 1. So mark the point 0. Now since it lies between 0 and 1, you can take 1 as much as far as you want, because you do not have to worry about marking point 2 because you do not need it. Okay, that is why it says that firstly approximate where a number lies. Now let us take 1 here and let us take minus 1 here. You can choose a pretty large scale, okay, because obviously you do not need 2 or 3. Now it says that try to write all the integers present on the number line which are of your use with the same denominator as your number. Okay, so I can write minus 1 as minus 3 upon 3. I can write it as 0 upon 3. Okay, I can write it as 0 upon 3, and you can write 1 as 3 upon 3. Okay, we have written it. Now what? Now you can see we have leveled the ground. Now all the denominators are same, so you just have to follow the counting between 0 and 3. We know there is 1 and 2, so where it will be? It will be at equal spacing from 0 and 3. So mark 2 points at equal distance. First point will represent 1 upon 3 and the second point will represent 2 upon 3. Okay, so 0 upon 3, 1 upon 3, 2 upon 3 and 3 upon 3. Similarly here the first point will represent minus 1 upon 3 and the second point will represent minus 2 upon 3, and thus you have represented the rational numbers, required rational numbers. So this is the representation of 2 by 3 on number line, and this is the representation of minus 2 by 3 on number line. You can see the method. Again, if you want to give names, you can give names. Let it be O, let it be A, and let it be A dash, and let the required points be P and B dash. Okay, so it is your choice what name you want to give them. But what we did in the second method is, firstly we have identified that where our number actually lies. That is, we have identified the smaller and greater integers, immediate smaller and immediate greater integers between which our number lies. Then we have what we have did is we have made those integers into a fraction by writing the same denominator as that of number. And now the ground is leveled. Since the denominators are same, you just have to follow the counting, and you have to see that how many integers are between there. Mark that much points, and then you can select your rational number, right? Let us take another example to illustrate this method further. Again, I will talk about both the methods. So the first method simply says you have to represent 8 by 5 and minus 8 by 5. Draw a number line, simple number line, mark a point 0, then mark a point numerator equal to numerator, right? You have seen this, mark point this, minus 8, right? Now what you have to do is, now you have to divide 0 and 8, the space between 0 and 8, into 5 equal parts. So 5 equal parts, so you have to mark 5 points on equal distances. Okay, for 5 equal parts we have to take actually 4 points, not 5, because 1 point will divide it into 2 equal parts. 2 points in the previous question are divided into 3 equal parts, so 4 points would be enough to divide them into 5 equal parts. So let me take 4 points at equal distances. So we have taken 4 points at equal distances. Now this method says the first point is your answer. You can clearly see the first point would be, because you have divided the space into 5 equal parts, right? So this has also, this distance has become 1/5. So this is 0 by 5. This will be 8 by 5. So this will be minus 8 by 5, and hence you have represented your numbers. But you are very curious to know that what these 3 points are about. So let me tell you that what we did in the second method is same, that it is 8 by 5. Do you know what second number represents? Let me tell you. So first of all, these are your markings, these are your required numbers. Now let me tell you what these number represents. This second number will represent just double of this, that is 16 upon 5. Okay, clearly see that what you have done is you have multiplied all the number lines by all the points on the number line by 8. Because after 0 you always mark 1, but you have marked 8 here. So you are treating 1 as 8, so you have multiplied by 8. So if after 1 0 comes, then it will be 8 into 1, that is 8 upon 5. After that 2 comes, so it will be 8 into 2, that is 16 upon 5. After that 3 comes, so it will be 8 into 3, that is 24 upon 5. And after it 4 comes, so it will be 32 upon 5. And after 4, you know 5 comes, so 5 is what? 8 into 5, that is 40 upon 5. Okay, so you are very curious to know that what the other points represent. So other points are nothing but the table of the numerator, right, with denominator being the same. Now what the second method says in this place? Again, you have to mark a number line. Mark the point 0 in between. Now after approximating the number, we get that 8 upon 5 is equals to 5 plus 3 upon 5. We have break the number in such a way that 8 is break in such a way that there is one factor of 5 and the remainder. So you can say it is 1 plus 3 by 5 after separating, or you can clearly divide 8 by 5 and you will get 1.6. So you can say that yes, it is greater than 1 and less than 2. So 8 upon 5 is greater than 1 but less than 2. So if approximated it, so you have marked 1 here and you have marked 2 here. Similarly, you have marked minus 1, you have marked minus 2. So it is 1, it is 2, it is minus 1, it is minus 2. Now what this method says is that make all the integers with the same denominator, right? So we can write 0 as 0 upon 5. We can write 1 as 5 upon 5. We can write 2 as 10 upon 5, right? Similarly, we can write minus 1 as minus 5 upon 5, and you can write minus 2 as minus 10 upon 5. Now what you will do is that we've already approximated the number is between 1 and 2 and you can clearly see it. Now that you have leveled the ground, you have made all the denominators to be same. You just have to follow the counting. Between 5 and 10, what is there? 6, 7, 8, 9. So you will get 4 points at equal distances. So mark 4 points at equal distances and you can select your number. Similarly, you can mark 4 points at equal distances and select your number. Okay, so let me write the number. It will be 6 by 5, 7 by 5, and this is your required number, which is 8 by 5. Minus 6 by 5, minus 7 5, so minus 8 by 5. So you have just represented your numbers. Again, this is 6 by 5, 7 by 5, 8 by 5, 9 by 5, and this is 10 by 5, which is true. So it is that easy to represent rational numbers on number line. You can use either of the method. Okay, both are easy and both are pretty logical, right? So let us take another question, and this time let us take only the positive part, because the negative part is just the mirror image of the positive part, where we have considered the mirror to be on origin, right? So let us represent 7 by 4 on the number line. Again, both the methods. First of all, since you do not need to represent negative side, you can mark 0 on here, so that you have to make a small number line. It works. Mark 7 anywhere you want. Okay. Now this is your scale. Now since you want 7 by 4, so you have to divide 0 and 7 into 4 equal parts. For that purpose, you will need 3 points at equal distances. So we can mark off 3 points at equal distances, and the first point will represent 7 upon 4. This is 0 upon 4, 7 upon 4. What this represents? This represents 14 upon 4. This represents 21 upon 4. I told you that it is just the table of 7 with the base 4. That is denominator 4. And it is what? 28 upon 4, which is true. But we have to represent only 7 upon 4. So you can mark it like this. So you have just represented 7 upon 4. Now let us talk about the second method to represent the same rational number. Okay. Again, this time we don't have to draw the negative side. So you can take the origin here. Again, I can approximate 7 upon 4 is 1.75. So it is greater than 1 and less than 4. But again, you can do like this. 7 upon 4 is equals to 4 plus 3 upon 4, which is equals to 1 plus 3 upon 4. Now it is greater than 1 but less than 2. So you can approximate that 7 upon 4 is greater than 1 but less than 2. Right? So you have to use 1 and 2. So you can become a bit lenient and you can take a large scale, so it does not become congested, right? Because you don't have to draw the negative side. That is the benefit of approximating. You know that how much space you have to allocate, right? So now what we have to do, now we have to write all the integers so that their denominators become 4. So we can write it as 0 upon 4. We can write this as 4 upon 4. We can write this as 8 upon 4, right? So now we have already approximated that our 7 by 4 would lie between 1 and 2, and you can clearly see it. Between 4 and 8 there are 3 integers, 5, 6, 7. So we will get 3 numbers at equal distances. So you can mark like this. And in these 3 points, this is 5 by 4, 6 by 4 and 7 by 4. So this is your required rational number, right? So it was all about the representation of rational numbers on number lines. We talked about number line, line segment. We talked about representation of integers, whole numbers, natural numbers, and different kind of integers, right? What kind of integers? Some integers which are negative, positive, and 0. Okay, you all should remember that 0 is neither negative nor positive, and that is why we are choosing it to be the middle point of the number line. And at last we talked about the representation of rational numbers with different kind of denominators, both positive and negative. So this was all about this lecture. I hope you understood this lecture. Thank you for watching this lecture till end. I'll see you in the next lecture. Till then, goodbye.